Hello all, today in this video I'm going to provide the implementation details of Python in hard disk classification, and the input is a CSV files. So initially, as we will do, they have to import the libraries. The libraries which we have imported include the pandas, then matplotlib, cbond, numb, iteration tools, then tensorflow. Then from the sklearn we have imported the classification report, confusion matrix, accuracy score, then standard scaler, one hot encoder, train test split, then early stopping, then the layers from the models. Like, since we are going to do the artificial neural simple deep learning deep neural network classification, so we have to import the libraries, and we are also importing warnings if it is any up there, means to the avoid that we have imported warnings. Then we are going to load the data set and just seeing the details of the data set, what it is having and what it is type. Just for that we are just using the data set info, then describe whether it is null or not. Then we are just plotting by using the SNS plot. This is a binary classification model. This dataset hard.csv dataset I just download from Kaggle. So you can see there's a binary dataset, binary classification model. Then we are having, since we are having two targets, which is 0 and 1. Then apart from the SNS plot, we are also, and cross tab, we are also plotting it in an heat map. All the data, all the variables in the data sets are plotted in a heat map. And then we are just splitting the variables for training and testing. For that we are declaring x variable from target and also y variable from the target. Then we are splitting 80 into 20, so the test size is 0.2. If you want some other person, means you have to change the test size. Then we are giving to standardize the data set, we are just providing the standard scalar function to, it will just standardize both the training data and also the testing data. Then we are just founding the shape of the x train and y train, whether it is equivalent. If it is, the shape is not equivalent, means you may know there will some issues, shape issues, to just find out and clarify. So we are just finding the shape of the x train and the y train. So x train both is having 820. So there won't be an error with the layers, number of the layers size. Then we are just declaring the model by using the sequential. Then the first layer is the dense layer. In the dense layer, we are just calling our input dimension as 30. This input dimension is this one of the x train. This dimension only we have called. Then the next data layer is also the dense layer, and here the activation function we have used as the ReLU. Next is the also an dense layer, but in the last dense layer we have used the activation function as sigmoid, and the output dimension is 1, since it is an binary classification. Now we are just running, we have called the model, then we have to compile the model, and we are just importing what are the layers which we are having. You can see its output shape and all. So now we are just use the training the model by using the train function, since we are having 50 approaches, and we have also used early stopping. This early stopping will stop the call model if it is running in an uniform manner. In the early stopping, we are going to monitor validation loss for three approaches, that is patience, and then we have just called the x variable and also the y variable. In the validation data we have called the testing variable of x and also the y. So the approaches it has run, so you can see that the loss is decreasing and also the accuracy is increasing for every approach. For a better model, the validation loss should decrease for every approach and the validation accuracy should increase for every approach. So you can see in our model the same is going on, that is validation loss is decreasing and validation accuracy is increasing. So we can confirm that our model is a better model. Then we can just plot the these things, that is the accuracy and the loss in a plot. Then we are just going to calculate the parameters like the accuracy, precision, and recall, what we will confirm do for the normal classification. And since if we are using writing any papers or documentation, means it will be better for you. And finally we are just plotting the confusion matrix for this binary classification. So you can see it's a 0.86 and 0.96. So this is the code for disease prediction with using normal deep neural network model. So in the next thing we can next code we can see same heart disease prediction with convolution neural network. Thank you.